Okay, let's talk about the proof. So this was the big problem. I think it was worth 7 points. In the diagram at the right, line segment AD bisects BAC and is a perpendicular bisector of the line segment BC. Prove that B is equal to C, so that this is equal to this. So in order to do that, we need to prove the two triangles are equal. As soon as we know that this triangle equals that triangle, well, if they're equal, then these two angles must be equal. So that means that we're going to have to use that one, that one, that one, that one, or that one. I think it's safe to say that you need to have these memorized for the test. So you need to start going in a direction proving sides and angles based upon what you know. So this one didn't have like a nice like given or whatever, where it was kind of like written in a sentence, which is fine. Line segment AD bisects BAC. That's our first given. So I'm going to write AD bisects angle BAC, and that is part of the given. So that didn't prove a side or an angle, but it lets me prove a side or an angle. So if AD, this guy, bisects this angle at the top, BAC, what does that mean to me? Well, if it bisects it, it has to cut angle A into two equal pieces. And these are both angles of the two triangles I'm looking at, so that's great. So we have to name these angles properly. A lot of people wrote angle A as equal to angle A, which doesn't really make sense, because I'm talking about angle A. That's not angle A, it's part of angle A. And this isn't angle A, because that's part of angle A. So we have to be careful about how we name them. If I'm talking about this one, it's angle BAD, B-A-D. So I'm going to name the one on the left BAD, and I'm going to name the other one CAD. And why do I know that? I know that because AD bisects BAC. So I know that I would just put the definition of a bisector, or if you wanted to be really specific, you would say an angle bisector. And I just proved an angle of my two triangles. So out in the column, I put an A. And now I know that I need maybe two more sides here, or a side and another angle. I know for sure I know a side because AD is part of both triangles. So if I say that AD is equal to AD, I have now proved a side right off the bat. Now, if you remember on that sheet that I gave you guys as part of the pretest that had all the properties listed on it, the property that says everything is equal to itself is the reflexive property. All right, so I've now proved an angle. I've now proved a side. So I'm going to be looking probably at one of these up here. So next part of the given is I also know that AD is a perpendicular bisector of BC. So AD is a perpendicular bisector. Now, that's part of the given. So a perpendicular bisector, and you have to memorize this because you're going to deal with it a lot next year in high school. A perpendicular bisector, this line AD, it cuts the line into two equal pieces. Now, I already used one slash here, so I'm going to use two for that one. So you can tell right here, I might think that I'm done, but I have side-side angle, which is not this. It would be this if that angle was down in here, right? But it's not. But what else do I know because it's a perpendicular bisector? It's a perpendicular bisector. So that means that it also has to make a perpendicular line with BC. So now I'm able to say Well, I'm actually able to do a whole bunch of things. I could do angle, side, angle, but I'm going to do, let's see here. I'm going to do angle, side, angle, actually. I could also do side, angle, side, but since I've proved this angle and this side, I could just do one more step by saying that angle BDA is equal to angle CDA. It's really important that I label these like this. If I just say angle D, I don't know if I'm talking about the left or if I'm talking about the right. And I know that by the definition of a perpendicular bisector. And that was an angle. Now I can talk about the triangles being equal because I have it. I got that one right there. So triangle BAD, let's just name it BAD, is congruent to triangle CAD. Now if you got this far and you stopped, I only marked off a couple of points because you got most of the way through it. You've done all the hard work. Now that the triangles are equal, we can say anything about them is equal. So since these are the same, this must equal this. So angle B must be congruent to angle C. And I don't have to name them with 3 letters because there's nothing I could confuse them with. So when you do that, after you prove the triangles are equal, the thing that lets you prove their parts equal is called congruent parts of congruent triangles are congruent, or CPCTC. And that always comes after you prove the triangles are congruent. Okay, that was a big one. It was totally worth a lot of points, and it took up a good part of our video here. But I think I have time to quickly draw this, which was a big issue for a lot of people. So on this one, AB, using a compass and a straight edge, AB needs to be one of the sides of the square. So if you did something that you made a nice big square, but AB wasn't one of the sides, it was wrong. So what I'm going to do is I know that I need to get a 90-degree angle right here. So a great way to do that would make a perpendicular bisector right here. But I'm going to have to double this line. Now I think you guys are better with this since we've been doing Euclid in class. But if I'm going to double that line, all I have to do is go like that. So now I have effectively doubled this line and I got some random point. Whenever I make a random point, I usually just call it X. Now it's really easy for me to do a perpendicular bisector of XB, and the problem is not done, but close to being done. So I'm gonna go here and I'm gonna go like this. Oops, my compass moved. So when I make my perpendicular bisector, I need to go over halfway. And then I'm going to make this one like that. Okay. And now I'm going to connect these two. Okay, now I've constructed a perpendicular bisector. I got my 90-degree angle, and I'm going to build a square out that way. So I know that if this is AB, this must be point C, and these two have to be equal because they're both the radius of this circle. That's a radius, and that's a radius. So now I just need to get point D out here, and I'm done. So in order to do that, I know that this side has to be parallel to this side because it's a square. So I'm going to draw another circle, and I'm going to give it the radius of AB or AC, because those two should be the same distances. So set your compass to that, and now all I have to do is draw a circle around, that's that size. I have to draw that circle around C and that circle around B. And I only need this part because this is the only part that I care about, is where these two cross out here. And I'm going to go like that, and these two little lines there, that shows me that you know that that's the point out there that is the same distance and parallel to the third side, and now, boom, I have a square. Okay, that's video 2. I'm at 10 minutes.